algebraic expression. Rational algebraic expression is an expression which can be expressed as ratio over quotient of two polynomials, provided the denominator is not equal to 0. It can be written in the form P over Q, where P and Q are polynomials, and Q not equal to 0. Take note that. So we have the ratio over quotient not equal to 0. So take note that again and again. Examples of rational algebraic expression. We have 2x plus 4 over x minus 6 if x not equal to 6. Why we need to do this? According to rational algebraic expression, if this is x becomes 6, or we're going to substitute the value for 6. So 6 minus 6, when we substitute 6 here, minus 6 is becomes 0. So we're going to do this one later as not permissible or permissible values. This is only the example of rational algebraic expression. Another one is 1 over x cubed. If x not equal to 0, why this is not equal to 0? So because if this one is become 0, we're going to substitute 0 to x. This becomes 0, the denominator becomes 0. So take note, according to rational algebra expression, is not equal to 0, the denominator. 2x plus 1 over 3x minus 5, if x not equal to 5 over 3. So if this one, the x here, when we substitute 5 over 3, and when we multiply it to this, it becomes 5. So 5 minus 5, it becomes 0. This is not, or this is the permissible values, not permissible values. So those things are not permissible values because the denominator becomes 0. So this is the examples of rational algebra expressions. So how can we determine if the given expression is not rational algebra expressions? Take note, number 1, it has fractional exponent, where a, the exponent is 2/3. This is a fractional exponent. When you see this one, it determines not rational algebraic expression. Number 2, it has square. There is square of a, or the exponent is a fraction. The same with this one. So again, if the exponent is fraction, it becomes the square, or the square root of a. So when you see the square root, or the radical sign, symbol, or the exponent is a fraction, it determines not rational algebraic expression. Let's try. Determine if the given expression is rational algebraic expression or not. Write your answer on a separate sheet of paper. By this time, we're not going to write. We just say if this rational algebraic expression or not. Let's go on. Number 1 to 10. We have number 1, 6x cubed. Is that rational algebraic expressions or not? Alright, that is rational algebraic expressions. Number 2, 1 over 8xy negative 6. Okay, that's rational algebraic expression. Number 3, 1 over 7x negative 2 raised to negative 2 plus 4. That is rational algebraic expressions. Number 4, square root of 2x. That is not a rational algebraic expression because of the square root, because of the radical sign. This is not a rational expression. 5, 7xy. So that is a rational algebraic expression. Number 6, n raised to negative 1 and n5. So I said n5, that's not n5, n raised to 5s. So that is rational algebraic expressions. Number 7, 1 over x. Rational algebraic expressions. And this one is not rational algebraic expression. Why? Because of the exponent of the fractional exponent. 9, 2 over x. Rational algebraic expressions. And the last one is not rational algebraic expression because of the fractional exponent. Determine the non-permissible values in the following rational expressions. So focus in denominator. Let's have the example. 1 over b. Now the answer for this one is very easy. B not equal to 0. Because as you remember that the rational algebra expression has rule. So what is that rule? The denominator must not be equal to 0. So this is the non-permissible value. Okay, next, 2x minus 5 over x squared plus 2x minus 35. We have x squared plus 2x minus 35, and we need to factor this one. So x plus 7, x minus 5. Then after factoring, we need to get the value for x of each of factoring. Now, x plus 7, it becomes x equals to negative 7. The x minus 5 becomes x equals to 5. How is it becomes like that? X plus 7 when equals to 0, we have to apply the subtraction property of equality. So it becomes negative 7. In shortcut, opposite of this one, since the value for x is 1, so that's okay. We focus in the positive 7. Opposite of this is negative 7. And negative 5, opposite of this is 5. So just apply the principal subtractions of property of inequality. Next. So this is the final answer. X not equal to negative 7 and x equals to 5. Why? Because when this one becomes negative 7 and 5, when we substitute here, then it becomes 0. So this is non-permissible values. It's values because they are two number. Next, x plus 7 over x plus 6 over x plus 7. Focus in denominator. So x plus 7 equals 0. Again, opposite. That's x equals negative 7. We're going to do the opposite if x is divisible 1. No. So x equals to negative 7. So this is the answer. X not equal to negative 7. Another example, 2a minus 5 over 2a squared minus a minus 6. 2a squared minus a minus 6, we're going to focus on denominator. And then to factor this one, we need to apply the general trinomial where a greater than 1. So we have 2a plus 3 and a minus 2. For 2a plus 3, we're going to do this one equals 0. And then apply the principles of subtraction of property of equality, and aside for that, divisions of property of equality or multiplication of property of equality. That's it. It's a lot of property we're going to apply here. Now, so 2a over 2 equals negative 3 over 2. I said a while ago this is opposite, but we have the number for a, so we need to cancel the 2. So if we need to cancel this one, we need to divide it by 2. Same here, both sides. And then cancel 2. And then the answer for this one is A equals negative 3 over 2. Same with this one, A minus 2 becomes, since this one, the A is divisible by 1 here. So let's have the answer for A minus equals to 0. So that's opposite. A equals 2. So the answer for this one is this one. A not equal to negative 3 over 2 and A not equal to 2. Which of the following is not a rational expressions? A 48x, B square root of x over 6, C 4x plus 2 over 6, or D x squared plus 3x plus 2 over x squared minus 5x minus 4. So, not rational is indicated. So the not rational here is letter B because of the square root or the radical sign. In the expression 3x plus 5 over 4x minus 3, x must not be equal to, so this is we're talking about the non-permissible value. So not not be equal to. So the answer for this one, when we get the value for here and opposite this, and since we have 4, this is 3 over 4. So 3 over 4, where are you? Oh, this letter C. Right. So this is not be equal to 3 over 4. Why? Because when we substitute here the 3 over 4 and then we simplify it, it becomes 0. So it's not permissible in rational algebraic expression. Alright, let's go to this one. Determine the non-permissible values of the denominator of rational algebraic expression. Write your answer on a separate sheet of paper. Show your complete solution. We have a minus 3 over a squared minus 3a minus 40. Focus on denominator. So when we factor the denominator, we have a minus 8 and a plus 5. So write it out. The equals 0 and then opposite, since the a is divisible 1, a equals 8 and the other one is a equals negative 5. Therefore, the answer is a not equal to 8 and a not equal to negative 5. That's it. For the quotations, this is it. Those who think it is permissible to tell white light soon grow colorblind. That's according to Augustine of Malay.